Welcome to applications of L'Hopital's rule. So recall when we were talking about L'Hopital's rule deals with limits. Right? So L'Hopital's rule deals with limits. Right? And then specifically limits that are in indeterminate form. Which means if we're going to apply L'Hopital's rule, then we must be dealing with limits. So any applications of L'Hopital's rule involve limits. So a couple of places where we've seen limits in this class, and then we can talk about if they apply or not. We've seen limits when we did the definition of a derivative. This would be a rather strange place to use L'Hopital's rule, since L'Hopital's rule involves the derivative, and this is the definition of the derivative. So it would be kind of a strange place to see limits, or to use L'Hopital's rule. So we don't usually use L'Hopital's rule for this. Unless we're dealing with a function that we don't know how to take the derivative otherwise. But in doing that, we're going to have to take the derivative anyways, right? So ultimately, we're not going to use this, right? So when we do our definition of the derivative, we have f of x plus h minus f of x. If you don't know the derivative of f, then how are we going to use L'Hopital's rule, right? Next up, we saw limits with curve sketching. So this can apply if we're trying to figure out asymptotes. So for asymptotic behavior. Right, if we have a variable x value where the function's undefined, we can check for asymptotic behavior, or if it's a whole, right? And then we can also look at end behavior, which is a limit at infinity. So this is another place we could have seen limits. We didn't worry too much about end behavior or asymptotic behavior. And then one more place where we've just recently seen limits was when we were doing Riemann sums and then taking the limit to get the definite integral, right? So using the Riemann sum, with the limit to find a definite, or to find a definite integral. Again, we have quite a few techniques for finding definite integrals at this point. And the Riemann sum was certainly not the most pleasant one of them. And then taking limits of that Riemann sum was not necessarily the most pleasant, but this is a place where theoretically we could use it. But our primary one will be curve sketching. So this will be the main situation where you could use L'Hopital's rule. In Calc 2, you may wind up using it for proving that sums converge. And there are a few other places where you might see it. But for Calc 1 material, curve sketching is the primary place where L'Hopital's rule might apply. And just limits in general, right? So that's just sort of a very quick where this might fall into Calc 1.